All right, I'll send you guys material after class of just the stuff that we go through as well, just so you can have it. This is just a starting point to go through. So I guess you guys have done a bit of Grasshopper so far, right? You've had like 4 classes or something. Basically, Python can be used very similarly to RhinoScript, if any of you guys have ever done RhinoScript before. It offers all the functionality that you would have there, but it's actually much, much better. It offers a lot more. This is just sort of some bullet points of that. We could run all the functions that we could run in RhinoScript, but Python is object-oriented, which we'll discuss a little bit later, but that gives us a lot of flexibility. It's much faster and cleaner, and also if we get into any other platforms later on, you can write Python in all of these other platforms, so Rhino, Grasshopper, Maya, Geomagic, SoftImage, Revit, and many other softwares. Okay, so I've given you guys a few resources here which I'll pass on, but basically I think that it'll be really useful to you to go to this first website. If I can, okay, does it come up here? Sure. Okay. Sure. Sure. Okay. This is just the first resource that I'm going to put in that thing that I'm going to send to you guys, but this is a great place to learn just about Python itself. So exiting Rhino from this equation for the moment, just thinking about Python and wanting to learn the syntax of Python, learn all the inbuilt functionality of it. It's a really strong language. This website's very simply written. So for example, if you click tutorial here, this will bring up a host of from like the simplest tutorials to more advanced things for crazy programmers, you know. So I would go through this. If you have any questions, this is going to be a great resource for you. Looking back. So also within that, there are these sort of other sublinks for specific documentation questions. So if we go back through here, language reference, so syntax and language elements, library reference. If we open this up, it starts to give us all the sort of functions that are built into Python itself. In terms of Rhino for Python, I would suggest this website. So I would look through, there's very simple tutorials in here as well. It's a good starting point in terms of learning just really basic use of this in Rhino as well. So when you're outside of class, you can learn that way. And also there are forums here, so as soon as you have issues, you can also look through these forums, and a lot of that stuff is going to be answered for you. And then finally, a bit later, we'll get into writing Grasshopper components as well, so we can kind of write our own code within Rhino, because it has sort of a great editor for debugging and setting up your code, looking up all your Rhino functions very easily. But once we sort of set up and implement our code there, we can then bring it over and start to write our own components in Grasshopper, so you can start to use all the functionality of Grasshopper, but also run that through your own codes as well. So this is where you can download those components as well if you want to start messing around with that. So to start off, you're going to need Rhino 5 in order to run Python, and once you open up your Rhino window, you just type in edit Python script, and that's going to bring up your script editor. So surprisingly, this inbuilt editor for Rhino is really, really good for what we're going to do. So we're going to write all of our code in here for now. You can see sort of on the left here, these are all the documentation. So for example, Rhino script syntax. Anything that are your sort of RhinoScript functions that you're going to run in Python, there are links to the documentation here. So for example, if I want to say I want to add a point to my document, I can very easily go in here, locate add point, double click that, and you can see that, within the editor, right below, you're going to see that there's a sort of very, very simple answer as to what this particular function needs and what it returns in the end. And I'll explain all, what these functions are and what that means. But in general, this is a really good reference. So you can just simply scroll over something and get information on the bottom. Or if you double-click these things, it's going to open up the documentation, and you can find out. It gives you an example as well as all the things that that particular function is asking for to input to run it. And then it's going to give you the information that's going to return after you run it. Also within this, there's a reference for all the Python functions that you've imported into this particular editor. So if you click this sort of Python button on the left here, you'll see all of these sort of inbuilt functions that you can run that are inbuilt to Python itself. Okay, so as a starting point, we open up the editor. We have a clean slate. There's nothing in there. Let's just start going through some of the basic syntax of Python itself. So imagine in Grasshopper, what you're familiar with right now is you want to run a function, or you want to, let's say, import some points that you've drawn in Rhino. So you pull down a parameter for points, let's say, and you input information into it, and it's sort of a visualization of data being tracked through your sketch. Imagine that this is very similar, but every single thing that we have to do, we have to write, obviously. As a starting point, generally speaking, Python code is read from left to right and from top to bottom. So just beginning, the first thing you write is the first thing that the script editor is going to look at. References to other things that you will come across as you start to put in, let's say you write a function into your code and you come to that function and you're actually running it. It will then look for the information to describe what that function is going to do. We'll run the function and then it will return to exactly where you were in the code. So again, you're just breaking it down in the order of operations. Python is case sensitive. So for example, capital A is different than a lowercase a. So if I really quickly write in here a equals 5 and little a equals 6, and I just said print a and it returns 6. If I print capital A, going to return 5. So those are two different variables. Also, as we go further into the code, you'll find basically everything in Python in terms of order of operations, and when there are loops, for example, that you will find that you'll run in your code, everything is based off of indents and spacing. So, for example, right now, these two variables are all the way to the left, for example. If I hit tab and indent, that starts to indicate sort of breaks in your code. So I'll just open you just to give you an example. Let's go. So for example, this is just a code that was written, right? And as you start to scroll through and you see these sort of 4 dots here, that means there was a tab. So there's space in front of the code. That is actually very specific. If, for example, right here, if I were to run this, but I only had, let's say, 3 spaces there, that would cause me some sort of issue. So that's one thing that you have to really be careful of, is making sure that you always know how much you've indented. which in this editor is really clear because it's going to show you these sort of little dots, and you can see that this kind of starts to organize all your code. As you look through this, you can see that these things are set in at different intervals. So for example, this if statement, and I'll explain these things in more detail, but for example, this if statement, when it begins, is indented in. So everything underneath this is going to happen if, for example, this is true. And not until you get back to here does it break out of that if statement. So if that if statement wasn't true, you would skip all of that information in between. But just so you know, basically, like, you're organizing all of your levels of code through the amount that you're indenting. And it's called white space. In terms of, okay, so obviously we have variables, so they're going to contain data. So let's say numbers, strings of letters, whatever, Booleans, let's say, a true or false, could be contained in a variable. In many languages, you have to indicate which type of variable it is. Is it an integer or is it a float value? In Python, you don't actually have to declare that. It will automatically understand when you create a variable what it is. So for example, when I say x equals 5, and let's say I print x. Okay, so it knows that it's a 5, right? If I do print type, that's just an inbuilt function that's going to tell me the type of variable that this is. It knows it's an integer. So I didn't have to tell it was an integer, it knows that. And then in terms of the reason why there are all these sort of dollar signs or pound signs, this is a way of commenting out your code. So anything you write in here and you hit run, it's going to try and run that code. It's going to try and follow through and know what to do all the way through whatever you've written. But if you want to comment information out and have it either be skipped or you want to add little notes to yourself as you go through your code, you use these sort of dollar signs. So for example, this print type x, if I put a dollar sign, it's not going to run that. So I run this again, and it doesn't have that little int at the end because it didn't print it because it's not going to run it. So this is a way of kind of going through and commenting out what you want to do before you do it. And then we'll get into this a bit further later, but the scope of variables is important. So the word scope means basically how long that particular variable is going to be available within your code, and whether you write that as a sort of global variable or a local variable is going to determine whether it is actually available at different parts in your code. So this is just a touch point, but that's important to also understand at a certain point. And then as a suggestion at the end here, I think this is a really important thing to always follow. It's really dumb, but that's the thing with code. Whatever you write is what it does. So I would say the most simple thing you can do, first and second and third, is the most important. So I would say I would go through and say, what do I want to do? I want to draw a line, and I need 2 points. So I would go through and I would comment out, to draw a line, need 2 points. And then I would say, where do these 2 points come from? And this is sort of like writing out pseudocode. And it's a way of kind of outlining out what you want to do. And it seems really dumb, but I think in terms of when you first start out, it's really important. Sure.
Guys, so many of these points that Tyson is talking about, it's the first time that some of you are hearing it, okay? But don't worry about it because we are recording it, and as he starts to write the actual code, you begin to understand what he's trying to say, and when you come back to the recorded video, you can actually see and remember what he was trying to point out.
Right,
so
absolutely.
If you don't understand the concept, don't worry too much, right?
It's tough at the beginning. I'm just going to try and outline some sort of big points first, and then we'll kind of come back, don't worry. So we'll review all these things repeatedly, and we'll understand. Okay, so let's just go through sort of basics. I explained commenting. So to comment out your code, basically means the interpreter, which is what we'll call this this particular environment when we run it. It will go through and it will skip any code that you've commented out. So one way of doing this is using these dollar signs or pound signs. Pound signs. Another way of doing it is sort of 3 pairs of these, and that's anything that's sort of in between here and here will be commented out and skipped. Another function that I already sort of showed you real briefly is the print function. So anytime you actually, let's say, create a variable and assign a value to it, and you run your code, let's say, it will create the variable and assign a value to it, but won't necessarily print that information. It's just internal to running the program. So if you want to actually see what's inside that variable, one way of doing that is to print it. So when you're first starting out, this is a good way to check what you've actually done as you're doing it. So all you literally are doing is typing in print, let's say. So let's say I want to create a new variable. Let me just put it here. I'm going to create a new variable called x equals 5.5. And I want to print that on the screen. It'll print at the bottom of the editor. To run a function, in this case it's an inbuilt function, I type in print, open parentheses, and I have to insert information that this particular function needs to run. So in this case, I want to print whatever's inside of these parentheses. So if I put in, let's say I put in 6, let me put in x. Great, all right. Just show it here. I want to print x. That's going to display the information at the bottom. So this is also really important in terms of debugging your code, going through and looking at what you're actually doing, is step by step doing one simple operation at a time and checking it when you're first beginning, rather than writing, let's say, 10,000 lines of code and then trying it and saying, why doesn't it work? And then you have 10,000 errors and it's really hard to figure out where they began. So it's really good to be systematic about this. In this case, this particular function, it can be run without parentheses, to be honest. So you could actually run it like this. But typically I would use parentheses because most functions are going to run with parentheses. So I think it's better to use that as a sort of norm. Okay, so as I said, you have, let's say, variables. So variables contain information. They contain data. There are different types of variables. They contain numbers, letters, different types of information. And then you have functions. Functions do things. They take data and they do something to it, let's say. So as a starting point, let's say we have integers and floats as I went through. So an integer is just a whole number. So 0, 1, 2, 3, 4, 5. And a float is any decimal number between a very large range, basically. So we can create variables by saying, let's say, a letter or a name, my variable, whatever you want to call it. And set it equal to something. And now I've created that variable and I've assigned it a value. Let's say I want to, let's say I do this exact same thing again. Let's copy this into this other window. My variable equals 5. Let's say I write my variable next. Equals my variable plus 5. So in this case, I created a variable called myVariable, and then I ran it, and then I also created the same variable. I said the same variable will now equal itself plus 5. So when you're assigning values within that particular line, it will actually go through and it will read from right to left in this case, just to assign that value. So it's actually updated the variable because it came after in the script, and it's assigned it itself what it was previously plus 5. So another point is that you can also switch between types of variables. Let's say, for example, a particular Rhino function needs a float value as an input versus an integer. Let's say you're creating a point and it wants to have a float value given to it. It won't understand what it means if you give it an integer. So in this case, let's say you have a value and you just want to change its type from integer to float, let's say. These also act as functions. So in this case, my variable is an integer. If I move further down and I run and I say so now I actually inserted inside of this. So first I ran the function print, and print is going to print anything that's inside of its parentheses, which are these on the outside. Inside of that, I ran a function which is called type, and all type does is you insert a variable into it and it returns what type of variable that is. And inside of that, I ran float, which is a function that takes a variable and makes it a float. And when I hit print at the very end, you can see at the very bottom, it's now a float. Whereas the print that occurred right before that is an integer. So you guys have any questions in terms of this so far? And don't feel strange about asking like really simple questions about any of this stuff at any time.
Does it make any difference at any point where you put the space?
In terms of white space inside of the parentheses, let's say, so you're saying here, right?
Yeah.
Does that matter? No, not in this case. But if this white space was here, it gave me an error because it said unexpected indent, and it didn't understand why I did that, because there was nothing leading up to it that had any reason for that to happen. So then that's going to give you an error. One thing that's good, just a quick point as well, you can see here now that this has brought up an error, and this particular editor tells you which line that error is on. So that's the first thing you would do, is you would look at what's the syntax error. You can look a lot of these things up online very easily. If you just type in literally what the error is as a Python error, and there's also, on that website that I showed you, there's also some error handling information where you can find really common errors. But when this comes up, let's say you go right to line 11, and then you logically look at what it's telling you, try to figure out from there what it is, and then start to kind of deduce what the problem is from there. But that's why, like, when you first start, you're going to get lots of errors, and it's really important to kind of go through systematically, like one thing at a time, and just check things as you go. Otherwise, you get very frustrated because you have to now deduce what you've done wrong, through a layer of things.
Small point. If you have a look at that error, in the bottom of it says unexpected index. That means that it has extra indent in the beginning, or whatever problem at the end of the line. So you can kind of understand what you're looking for without having to know all the Python details and so on. Just have a look at the line and the syntax error that says in the bottom, that is indent error, unexpected indent, or whatever. You'll understand it over the time, I think, as Python, as Tyson is going to show some codes. But you can easily kind of understand what type of error you're dealing with, apart from very few scenarios that you have to look at.
Okay, so as a starting point, we have variables, let's say. Very basic variables are floats, which are decimals, integers, which are whole numbers. Very often we use them for counting, like keeping count of things or iterating through something and repeatedly doing it. We also have strings. So strings store, let's say, text information. Let's say we go in here. Say my string equals my dog. And we run this, and it just prints my dog, because that's what's contained inside of the variable. If I do this again and I print the type, it's going to tell me it's a string. So it's an str, which stands for string. You'll find that these things have sort of their own inbuilt functions in Python that you'll start to utilize after you get into this a little bit. For example, let's say, well, I'll show you real quick. So if we go back to this sort of page where there's a lot of information that's going to be useful to you, from here, we go in and we type in, for example, like as simple as in Python, in Google, you can type in, let's say, Python strings. Basically, immediately it pops up with stuff from that website that I gave you. If you click the first one, common string operations. So this is going to give you sort of all of these inbuilt functions within strings. So if you have a variable that is a string, you can run these functions upon that variable as an inbuilt functionality of that Python thing, object. And that's what these are. So as you want to do something, let's say, with a string, you should go online and find these functions and figure out how they will work with what you want to do. But as a starting point, this is just to show you, like, as a reference, you can easily come and find this information. We also have booleans. So another type of variable is a boolean. So that's like a, let's say, a true or a false value. So it always means true or false. So you can see that on the bottom, it printed true. So you'll find basically when you're writing your code, and we'll go into this a bit further later, but you can have, let's say, what's called a conditional statement. So a statement where you're coming along and you're running functions that you've written, let's say, and you want to draw a line if something happens. So at that point, you can write an if statement that says, if something occurs and is true, do something. So Booleans very often are a variable that will hold a value which is true or false. So for example, if you wrote an if statement and said, if my Boolean is true, do something. And it will go through and it will check to see if that statement is true. And if it is, then it will run what's underneath it. If not, it will skip whatever's inside of that if statement. Okay, so then if we have these, let's say we imagine that these variables are little objects in some way that contain different types of information. They contain numbers and strings of letters, and they contain these Boolean statements and other types of information. Let's say we have, let's say we want to keep track of groups of these things. So we don't, every time we want to, let's say, draw a line once, we don't want to have A, B, C, D, E, F, G for every single point. We want to actually contain information in something that sort of groups it together and organizes it. So inbuilt in Python and kind of utilized within Rhino very commonly is a list. It's just called a list. And it contains information. You can remove information from it. You can remove, let's say, x equals 5. You can put x equals 5 in that list. You could have y equals 2 and add that to the list as well, and then you have both of those things in that list. You can remove things from the list. You can take two lists and combine them together. There's a lot of different functions within them. So let's say my list, the way that I would write this would be like this. So it's open and close brackets. Right now that's basically showing an empty list. So basically, if you imagine here, a list contains information separated by commas, which are different places within that list. Each one of those places has an index number, so there is an order to the list that's important. So let's say I have my list equals open and close brackets. If I print that, I scroll down to the bottom. It's just showing open and close brackets, indicating that it's an empty list. So then if I run it again and I just added, let's say, 3 pieces of information, one way of initializing a list would be to just say my list, using the equal sign to indicate what's going into the list variable, open brackets, whatever will be inside of it, separated by commas, close the brackets, and that will give you a list which contains that information. If I want to pull out one thing from this list, let's say, so the first thing in this list is going to be in the first index number. Lists start from index number 0. It's an important thing to remember. Doesn't start from 1. So the first thing in the list is located in index number 0. So for example, if I want to say x equals, and I want to create a new variable called x, and I want to set that equal to whatever's in the first place in my list that I previously created somewhere. I would say that. So basically I would indicate the name of the variable, which is my list, and open and close brackets with the number indicating the index that I want to take out at that time, and temporarily, let's say, assign to x.
The reason why you switch the brackets from the front to the other one?
You mean from the print right above it?
Yeah.
Sorry, which one?
Don't you use now different brackets than, or it doesn't?
Well, basically, you use these sort of normal brackets to indicate anything that's inside of the list or to initiate it as a variable as a list. But like, for example, here when I just did print, I just used parentheses to run that function. So anything inside that parentheses is what it's actually going to evaluate with that print command.
Yes, and also one of the students is it a square bracket for the list or it's just a parenthesis? You could do it with the parenthesis as well, but it's then tuples that I would imagine that person would go through at some point. So just bear in mind it's always a square bracket for the list, and if you define it with a parenthesis, it's completely something else.
Right. There's various different types of these sort of compound variables that hold sequences of information in different ways. I think list as a starting point is really simple. It's very logical the way it's used, and it's probably the most common thing that you're going to use to sort of hold data. So I would stick with that for now. And yeah, so anyway, anytime you're setting up a list, you will do it with these brackets, so square brackets.
But if you go print type my list,
Mhm.
that be list.
Let's try it. Print type list. And then if I were to then add, let's say, print x, you can now see that x equals 0 because the first thing in my list was a 0. So if I were to go back up and make that let's say, a dog, so it's actually a string. The first variable in that list is a string, the second thing is an integer, and the third one is a float. So lists can contain different types of variables. Now if I print this again, or run this again, it's going to show dog in the end because dog is located in x because I set x equal to the first object located in my list. Yep.
How come you can put different types of data into the same list?
Sorry?
How come you can put different types of data into the same list? You declare data and then list
Right. Well, it depends your order of operations and sort of what you need the information for, I would say. But for example, you may want to have a list that contains, various different types of variables. Maybe it contains lists of things or something like that, and you have lists of points. But maybe those are coupled together with lines because you want to group those together in your sort of data structure that you're setting up. So there are reasons why you may want to have sort of different variables together. But you can always set up a list logically, right?
But it doesn't care about what
No.
variable it doesn't say.
No, that's one of the things that's really nice about Python is it's super flexible. but it's also something you have to keep track of, obviously, because it does have that flexibility, right? So you may, for example, you might end up having an error which, let's say, one of your functions needs a float value and it happens to possibly contain an integer. That happens sometimes, right? So you might have to have a, you know, you're going to have to keep track of things like that because you may have a list that accidentally contains also integers, right?
Yeah, the thing is that you don't ever have to declare the variables.
No.
So,
So anytime you, I mean, the sort of declaration of the variable occurs when you set a value to it, right? So you're not actually, you don't actually, like in RhinoScript, for example, you have to say int r, and then, you know, you indicate what that variable contains, right? Which ends up also creating a lot of issues sometimes with RhinoScript that you have to sort of finagle through and realize, you know, why. Python's super flexible in that sense. So you can reassign values to variables. You can change them very easily. So if I ran this again with my list, and I print x again further down. Now it prints 5. So you guys have any questions, any more questions in terms of any of these basic things so far? What's that? Okay. So there are also sort of inbuilt functions again with lists. So, you know, let's say you have an existing list that contains information and you want to add more stuff to it, but you want to add it directly at the end of the list because you're keeping track of an order of things. Like one example of this would be, let's say you want to create a line from a bunch of points, but you need to know the order of the points in order to create the line. You don't want the line to like start here, jump here, zigzag across itself. You want to create, let's say, a curve or something. So then you would want to have a list of points that are in an order that it's going to choose when it creates that line. And it's going to go through and it's go from point 1 to point 2 to point 3, and it's super straightforward. And, you know, it will always do, obviously, whatever you tell it to do. So let's say we have my list now. And I want to add one value to the end of it, for example. I would then say my list dot append and whatever I want to add. So let's say I want to add another variable or another value. So now you can see at the very end, it printed the last my list and added another value to the end of it. So basically, in this case, when you have a variable which you know is a list, that particular variable, I'll explain this a bit more later, is actually a class which contains functions and variables within it. It's a type, but it contains sort of inbuilt functionality that you can run with it. So anytime you want to run something that's within it, you use a dot and the function and parentheses in this way. So if I just keep doing that, it just keeps adding on to the end of the list. And you've seen, obviously, every time I'm pressing play, it's rerunning this program, and it's going through every single line of code, and then it's finishing. And there's no errors, so it's not giving me an error. It's successfully going through and printing all of these different lines. So after this program, in terms of how Rhino runs, after this program is finished, the information is sort of not retained necessarily. So that's why every time I run this again, if I were to remove all of this stuff that was at the beginning, and I were to write mylist.append another value twice, see it says my list is not defined. So it's actually going through defining all these variables and running your code in the order that it's there every time you do it. So I got rid of that stuff. It's no longer there in terms of how Rhino's concerned when I run this again. But again, that error message is pretty straightforward. It tells me to go to line 3. So if I had still had all of those lines deleted, I went back to line 3, I'd be able to track back and say name my list is not defined. Okay, clearly I had not defined it yet. I tried to run a function on a variable that I didn't actually create yet. So that's why it's giving me this error. Does that sort of make sense? I realize it's like super dumb and basic kind of to go through this, and it's kind of grueling, but it's like the only way to start, you know? So we'll get to some drawing stuff in a bit. Another inbuilt function of lists is to extend them. So that's actually to just, let's say you had 2 lists and you want to add the second list to the first list, you would extend them. So you would say, let's say I do my list dot extend, because that's an inbuilt function of the list variables. And let's say I put in open brackets 5 comma 6 comma no, or let's say true. Close brackets, so that's actually a list that's being created inside of those parentheses, and then it's being run using this function extend for my list. So then if you look at this now and print my list again, at the very end, it's added on that second list to the end of the first list. So that first list now contains all of that information in that order.
But append can only add a single value, but add a list.
Right. So you use append to add a single value and extend to add an entire list to the end of it.
Where can we find these inbuilt functions in the documentation?
Yep. So let's say I want to find out about these sort of functions for lists, for example. One easy way is to literally just type in Python list. First thing that pops up is data structures, which is within the tutorials. So it's going to explain to you very quickly. It gives you some really common used functions that you might use. So the first one is append, as I went through, so add an item to the end of a list. Second one's extend, as I went through, and then there are some sort of other functions as well. So there's insert, if you want to insert a value, and you know exactly which position in the list you want to insert it in. You could insert it into, like, let's say, location number 5, and it will be put in there. Remove, you can go through basically and remove the first item in the list that has the value that you put in parentheses here. Another common function, for example, would be sorting. So let's say you have a list and you want to sort that list, let's say from top to bottom, like the largest value to the smallest value. You can sort using this.
It will give you an error if it has string values, the list, or it will just give an idea.
Let's try that actually. I'm not sure what the order of operations for that would be actually. sure.
And then if you have a question, you can ask me, Jerome, over there, based on the distance.
Isn't this the case that you need to run this command on a separate line and then print test list again instead of printing a function?
Right, because you're saying the result is none, right? Yeah, exactly. Okay, yeah, so basically in this case what we had to do is pull it out of the print, run the function, because what it was actually trying to print was what that function returned. And it doesn't actually return any information, so that's why it was telling me none when I was trying to print it. So actually it's just a function that took the list as a variable, resorted the information inside of it based on its size, and then now if I print that variable itself, it's going to give me a return of that sorted list. Does that make sense? Also, strings act a bit like lists in terms of retrieving values. Let's say we create a string called my string equals my house, and I want to print, let's say, the first letter in that string. You can run open parentheses for print my string so it printed an M, so it pulled out the first letter in the string. So it deals with strings in this way, very similarly to lists. You can also look up the functionality of strings themselves, as we were before, by looking here, common string operations. A lot of these you might not need, but for example, at certain times you may want to, let's say, for example, you have a list of points that are in a text file from somewhere else for some reason. You might want to go through and actually take that list of points and separate it by commas and then convert that into a list. So those types of operations you may want to you may want to be able to basically strip away information, but also sort information by commas in a string.
When you have a list which contains numbers and strings and booleans, how does it sort?
Let's try that again, actually.
How does it sort first? I don't know, how do you, can you control how we sort? From the binary.
So let's try.
Small to big is
Yeah. You can also reverse a list. So let's say you could sort it from smallest to biggest, and then you could reverse it, and it would go from small, the reverse. So, okay, sorry. So our first one was my list. So if I run my list, This is something I think we could also look up in the documentation, but I think that most likely when there are values, let's say, that are not numbers, there's probably a set order in which when you sort a list and it has those values, it puts them in. So for example, the Boolean went first, and there's most likely a sort of norm for how it does that. I'm not sure in terms of order of operations if you had Booleans and strings and numbers. But here you can see it chose to sort based on the Boolean first. Then it sorted the numbers in order from lowest to highest. And then it sorted the string values. But typically you're going to be using sort to sort numbers. Let me know if you want to insert anything. Whatever. Okay. I'm going to just transition into how we can start to use Rhino's functionality. I realize that it's a bit quick and it's a bit disjunctive at the beginning, but we'll go back through and we'll repeatedly go through these things. And if you guys have any questions, just tell me. So I'll just give you a starting point so you have an idea of kind of how these things are starting to work together. So if I open up a new Python script, and it's a blank slate currently.
If I want to save this now, I just go and save as.
Yep. Just go and save as and wherever you want to put it, and it saves it as a Python file. Before I jump into this, do you guys have any other questions you'd like me to go through further with these sort of basics of variables and lists and how these things go together? Or talk any further about it?
How does it work with different softwares? Like, is it that you, like, the script needs to be written differently whether you work in Rhino or Maya?
It's a bit differently in Rhino and Maya, and I'll go into that in a bit, like specifically like how it works with Rhino after this. But yeah, in Maya you end up using strings quite a bit, for example. But the basic syntax and the basic way that you write code is the same, right? I mean, Python acts the same no matter where you write it. It's going to be based on basic variables, the sort of indenting and non-indenting, different sorts of flow control statements, such as like if, then, do something. And we'll get into that more specifically, but in general, once you know how that line of thinking works, it applies in other places. You just have to learn how that particular environment will react to it, right? So.
Are there ways to import Rhino scripts into Python, or does it all have to be rewritten?
Yeah, I think you'd have to rewrite it. You'd want to rewrite it.
You'd want to anyway.
Yeah.
And something, the colors on the text indicate different things, I suppose.
Right. Yeah, I mean, the Python, this editor has its own sort of inbuilt information, so it kind of will separate when you're running a function versus declaring a variable based on color. I'm not sure exactly, to be honest, I'm not sure exactly what the colors mean, but it is to sort of sort.
If something is typed wrong,
Yeah.
from the Boolean will not turn blue, right? Or, I mean, the
Right. Right.
Yeah, and you see like those functions like print, their color as well different than the comments.
Okay.
Yes.
Right.
Sorry?
That's a good question, actually.
What's the question?
Well, on a laptop,
Yeah.
keyboard is no hash to do the mantra. So
You don't have the brackets?
I mean, I have it over the 3. So maybe it is the concept.
See how it's in green? So that anything that's inside of that is going to comment out.
Or you should switch your keyboard language to United States. Yeah, that's
You like it?
well, that only changes if you have multiple languages. Yeah, plus you little more lines.
And yeah, so what you do is then you say, let's say, and then do it again. And then after that, what do you want? You're welcome. Is there anything you think I'm missing in terms of just as a starting point, stuff that I should be more
Not yet, I think.
in tune with, because it's so awkward when we first start, right? It's just
But I mean, it all comes with
One is RS. Okay.
one objective.
From here on, we write RS dot output.
Because it sounds a bit boring now with the X.
exactly.
I think it's
That's why I'm gonna jump in and just do some Rhino
I
things.
think that's a good one.
Just to get an idea.
Yeah.
so first. Let's
That's the question.
script syntax.
Sort of this, but we only use the listing for the sorted or reverse it, how we should call it.
Sorry, say that again. So basically, you create a list of information, right?
And then you sort it, or we do another time, but then we need the first one, so how to recall.
Right. I think what you would want to do then is create a copy of it initially. So basically, you could say, my list copy equals my list.
And then
Let me just double check this real quick. So I'm gonna have to do a shallow copy.
Thank you, by the way.
All right, this is going to be a complicated answer, but basically, what I had to do, I took that original list, right? I first tried to make a copy of the list like this, right? So I just set, sorry. So I just set it equal to my list, right? And then I printed both of them, my list and my list copy. In this case, it's actually linking to the variable. So in order, basically, as that variable got updated and changed, it carried that information and passed it to the other, to the copy. So what I had to do is what you could call like a shallow copy, which is I just added these the brackets to the end and this colon, which basically means copy everything inside that list, but create a new variable that contains it. So that was a way of copying the variable. Can you think of a simpler way of explaining that?
No.
Because lists are a little bit strange in that way. But yeah, that's one way you can create a copy, let's say, of a list so that it's no longer linked. It's a separate, let's say, my separate list, copy something at a certain point, and then the first list, let's say you can do whatever you want to it and change it and remove things, and the copy will stay the same. But this is, again, a kind of an example of like why you want to be able to sort of go through and keep printing things, because you may have done that, right, and thought that this was okay, and that now you had a copy that would never be changed, and then all of a sudden weird things start happening. Like why is this happening, right? So I think that's a reason to be systematic about it, especially when you're starting out.
actually doing what we just did.
Yes.
And by mistake, I put print float type my variable instead of type float my variable, and the other way around didn't work. What's the logic?
So you put the float outside of the type?
Yes.
So what you did, so you said my variable equals 5, and then you tried print float type
Yeah.
my variable, and it gives you an error,
Yeah.
right?
Yeah.
Basically, because type is going to return, type is not going to return a number, right? So basically, what you wanted to do is actually find the type of the variable after you ran float, right? So you need to go all the way to the inside of the parentheses in order to get there. Another option would be to do this. You could let's try this real quick. So in this case, I just took that, I ran that float function on my variable,
Yes.
which returns a value, and when it returns that value, it puts it into my variable again, right? Or I could say, to make it a bit simpler, now it's a float. Okay, so I'm just going to quickly go into sort of functioning with Rhino and how you'd start to just very starting off interface with the Rhino environment. So basically imagine that all of these functions, for example, when we were looking at lists, so list has a function called append, right? And that's inbuilt in Python itself. When you start this editor up, there is a search path that's built into this where it actually searches for files in a specific location to import any of these functions that you want to use, basically. So very quickly, just as a point of reference, if you go up to Tools and Options, first thing that pops up is Module Search Paths. So what this is actually telling me is these are the locations where it's going to look to find scripts, modules. Module is another name for like a collection of functions and data in Python. And so if you were to open this up, this is going to actually, every time you open up Python editor, it's going to search in these paths. So you can add a path. Let's say you have your own code that you want to be able to import in and have stored in a file somewhere, and you want to just run a function that you've already created somewhere else. You could put it in one of these folders or create a folder and link it to it here, and you would then be able to import your information. I mean, the reason why this is important to understand is that all of the functions that are written in Rhino are actually written in Python code in terms of the Rhino script syntax. So if we're gonna write let's say a function such as add point, let's say. So if we click this on the side of the editor here, these are the documentations for Rhino. So if we open up Rhino script syntax, this has all sort of Rhino script functions. And when I say Rhino script, they've converted them over to Python. So we're actually writing it in Python. But originally, these are sort of all the functions that you could write in Rhino script. So that's why it's just labeled as Rhino script syntax. But anyway, if we open that up, that's going to give me sort of all the functions that I can run within Rhino. So such as add points, adds one or more point objects to the document. If I open that up, it says syntax. So first, how you would write it. So when you want to write your function, this is kind of indicating how you would start to write the function to call this particular one. And then it's going to say what's under parameters. These are the things that you need to insert into the function to run it, basically. So in this case, it's only asking for one thing. It's saying points required. So it requires that you give it points. It says it will accept it as a list or a tuple. So basically, if you give it a list, such as the lists we just created, and it understands those things as points, it's then going to be able to, basically a list of coordinates, so in threes. It's going to then take that list and convert it into points. So if it's successful, this where it says returns, it's telling you what is actually going to be returns when it runs that function. Definitely. So yeah, exactly. So when you run a function, you have data, and you put the data into the function, and the function does something with the data, and it outputs something at the end. So in this case, when it says returns, in terms of these Rhino script functions, they return something back to you. So in this case, they're going to return points, right? But here, where it says under returns, list of GUIDs, I'll explain this further as we go, but basically what a GUID is literally, it's just a reference number. It's a number that references a point in your document that you've created. So you imagine that every time you open up Rhino, it's creating a new document as the sort of scripting language understands. And this, when you create, let's say, a new object in your document, it's going to create a little number that's a reference to that. So actually when you return this value for add points, or let's say you run this function for add points, it's going to return a reference to the object in your document. So it's as simple as that. But it's, you know, we'll go back to it. Okay, so to go back to what I was sort of explaining, and if you don't get this right now, that's no problem. We'll go back to it. But basically, when you go into Tools and you go to Options, it gives you these links to these different locations. All of these are just Python files that were written by Rhino, basically. They rewrote the functions that you could normally use in Rhino script in Python, and you're literally just calling these functions as if you wrote your own function and running it. So if I were to double-click one of these things, it brings me to the folder that it looks at. If I were to open up Rhino script folder, This contains sort of all the functions that I just had on the left tab over here. So all of these over here are contained in these, which basically these are called modules, so they contain all these functions. So let's say I open one, such as curve. Sorry, a second. If I were to open up one of these files, which is what you're importing, it actually has all the definitions. So all of the functions that you're running that Rhino's written you can access yourself. You could change them if you wanted to. So the only purpose of me showing you this is that it's as simple as someone else wrote functions and then allowed you to use them, right? So by importing them into this editor, when you start up this editor, it automatically looks in this location on your computer. It finds these functions, and in order to use them, all we have to do is import them, basically, right? So the starting point when you open up a new Rhino document and you want to start writing your own Python code functions, right? If you want to use any of the Rhino functions, the Rhino syntax as it's explained here, first thing you have to do is import that module, is what it would be called technically. So basically, you would go in and let's say the first thing you have to write is import RhinoScript syntax. So what that's actually doing is looking in the place on your computer that it's already looking naturally because it's in that sort of search path. It's finding a file called RhinoScript syntax, and it's opening and it's basically importing all of that functionality into this document so that you can just start writing these functions really easily. Here I wrote as rs, and the reason why I did that is now anytime in my document, because I've imported those modules, that I type rs dot, it automatically starts to bring up the possible functions that I can run. So I could go down and I could start to write add point. This is called code completion. It kind of automatically starts to bring up the functions that are listed underneath that thing. So I could click add point, and if I hit open parentheses to run it, automatically you can see at the bottom of the screen it starts to give me information about what add point, what you need to input into add point to run it, and what it's going to return. So it's the same as if I were to go to the left here, as we did, find add point, double click on it, and open it up in the documentation, and it gives me very similar information, along with some example, let's say. So in this case, in the example, they write import RhinoScript as rs, so that's the first thing you have to do in order to use RhinoScript functions. And then they use rs.addPoint, and they insert basically a point.
Maybe good to mention with that is that you can just write import RhinoScript syntax as well, right?
Yep.
But then you have to write RhinoScript syntax dot add point every time that you want to use a function. So it's basically just saving letters, saving time, right?
Yep, absolutely. So you could, like you just said, you would then have to go RhinoScript syntax dot, and now I have to type everything. So by putting that add, it makes it a lot simpler every single time because you're going to run a lot of these functions.
It's a grasshopper.
Yep.
You still use import Rhino syntax.
Yep.
Through the grasshopper.
Yeah, when we get to the grasshopper stuff, it's very, very similar. It's almost it's almost identical, but there'll just be some things we have to tweak in terms of the inputs and the outputs. But yeah, you do exactly the same thing. And also within the grasshopper component that they've developed, it's the same thing. If I type in rs dot, it's going to start to pop up functions as well, like add point. So it's very similar. in terms of an editor, but this is a little bit, in terms of developing things and looking at what we've already, debugging the code, basically, this is slightly better, so that's why I like to write in here and then kind of import it. Do you guys kind of get that so far, or do you want me to sort of explain that again? So basically, any of these functions that we want to write now, because we've imported, sorry, now I can run any of these Rhino script functions, basically, but in Python. So, all right, so let me just add a point first. The simplest thing ever. We're going to go so I'm going to, as a starting point, I'm going to write down sort of pseudocode what I want to do, what do I want to accomplish. I want to add a point, that's it. And I want to assign that point to a variable, let's say. So first, let's say I'll create my point location variable. Set that equal to a list. And I'm going to say 0.10.20 for the x, y, and the z values. So if I test that and I print it, it just prints my list. Alright, so then I'm going to create a variable, and I'm going to say it's my point, my PT. And now I'm going to run that function to create a point and return. Basically what it will do is create a point in the document, and then it will return the identifier for that point. And it will place what it returned in this variable, my point. Okay, so I ran it, and it didn't give me any errors. I didn't say print, so it didn't print my point. It just created it and put it in a variable called my point, which if I write further code, I can use. But let's look on the screen. You can see it created a point at that explicit location in space. Now, if I run the same code again, I'm just going to click undo. Let's say now I print my point afterwards. Now it created the point. First it printed the location, so the list that I created first. Then it printed basically what was returned from this function. So as I said, this particular function, if I open it up and I look at it, here it says returns GUID. So GUID, the identifier of the new object. So it's literally just like a serial number for this object. And then you'll see when we ran it, it shows you the serial number. I mean, this is kind of arbitrary. We don't actually care about this number other than the fact that it's a reference to something. So we want to store this reference in a variable that's simple. So we stored it in a variable called my point. So if I now want to use that point for something else, I can use that as a variable because that variable now contains the reference to the actual point in Rhino. Does that make sense? Just try to do something simple like exactly like this and just see if it works real quick.
I gave 3 locations for the point, 0, 10, and 20, for what?
So for the x, y, and the z coordinates for the point, so basically I just created a list which contains 3 numbers.
Why do you put my PT inside of parentheses on that last one and not on the my point location when you print?
Right. So basically, if I were, when I print this, let's say I'll move this real quick. Okay, so it goes through now the way it's set up, and it creates a list of 3 coordinates to indicate the location of the point, and then I run this function rs.addPoint using those coordinates. It runs its function that I showed you, wherever it's been written. So it's going to run this function, which we know is going to return a GUID value, which is just a reference to that point in the document. So basically what I'm saying my point equals is that reference in this case. So it's returned that reference to that point in the document. And so now if I print my point location after it's created that reference, right? It's still going to print the original variable, which is just a simple list, still exists, and the second one that I printed here is just the reference number, because that's what the function returned and then assigned to that variable my point. So if I run this again, you see it still prints first the list, because that's what's still in that variable. We haven't changed it, and also it prints the reference number, which is in the my point variable.
Way to access directly the values of my point?
In terms of now, once it's returned that reference, how do we then?
What's my x?
What's that?
What is the x of my point?
Let me try something really quick. I can't remember if this will work. Otherwise, it's a bit complicated. It's not going to work. I mean, this is going to be a bit complicated as a starting point, but I'll get into this later. But basically, I ran this function. It created a point in space, right? And as I said, in Rhino, it's basically every time you start it up, it has a new active, what it calls an active document. So it's like the document that it's created when you start it up, right? When I run this function, it's going to add a point in the document, right? And it's going to create a reference number. And there's sort of two aspects to Rhino. There's the actual object itself, which actually contains the x, y, and the z values, right? And the information that point is in reality geometrically. But then it adds that to the document using this reference number. It's a bit complicated, but there is a way to get to the object information. But as a starting point, but basically we'll stick with this for now. Just basically that this particular reference, if we want to use this point in another Rhino script function,
I want to move it and see what happens.
right? Does this make sense so far? Just as a starting point? Do you know a better way to explain that, other than objects versus identifiers? Do you know what I mean by that? Without getting super complicated?
Yeah, it's pretty abstract.
Yeah.
That's tricky.
Yeah, it'll become more obvious through time, but
But on the other hand, it's like many things in scripting, you can do it in 1,000 ways to describe it. You could as well make a rhino.geometry.point3d, right?
right.
Then you do have x, y, and z coordinates in the object, in script. So, yes. So you're not directly adding it to the geometry of Rhino, but you're keeping it inside of the script. So that's a different kind of
So then basically you've created, let's say, a vector in space, but you actually haven't added, like you look in Rhino and there's no point there, right? You could create a variable that's just a vector, let's say a vector in space that locates like 10, 50, whatever. And you have that vector, you could save that vector into a variable, and you can use that vector to move things, you can use it to locate points, right? But in this case, I'm just showing basically how we would run it to actually create a point in space.
You can't, once you create it, you can't really control it.
It just goes with the command as point coordinates.
Sorry?
You just go as dot point coordinates. And you print it, you add the
you get
no, this point. No, it's not.
no, that's selecting from command line.
What's that?
This is selecting from the command line.
Right. So that takes an object. Okay. So basically what you'd have to locate, so in this case, you have to locate something where you can actually put into it. Like, for example, like if you've run this function, you've created a point, and you've added it to the document, which means it exists. You know, it's not just a list of numbers that represents a point, it's actually a point that exists in Rhino, right? So then what that function returns to you is a GUID, which is a reference, as I said, right? So then in order to get those point coordinates out of that particular object, as opposed to the first list that I used to create it that just had the coordinates, right? I would actually have to use a function where I can input that reference. So in this case, this is a function also in RhinoScript that you can run, where you input that GUID and it will give you the point coordinates back as a return. So. Another thing I'll show you really quick is that if, let's say I add to this document something here, if I click in this sort of gray area alongside this, and this little red bubble appears, this is a way of going through and sort of debugging your code of what you have so far. So basically it will go through up to the point where you click this, and it will list in the bottom what all your variables are, what they contain, and what types of variables they are, basically. So this is also really useful in terms of, you can print your values as we're doing above, which is also, can also be specifically useful if you want to kind of nest that information in a specific place to locate a specific problem in your code. But you can also just list all the information up to a certain point. So let's say I click this little red bubble and I hit play. It runs the code up to that point, and then it brings this up at the bottom. So this lists all the information basically that's in the document currently. So here, for example, RS contains a module, RhinoScript syntax. And I can click these little sort of plus signs alongside of it to open and expand that as a list and look at what's inside of it. If I open that up, it has all this information that's contained in that module, basically. And you could keep kind of unrolling the different layers of that. But let's just look at our variables that we created. So there's two variables here. One, my point location, so that's the variable we created first. And it tells me it's a list, so it's a type, it's of type list. It contains 3 items, so then if I open that up, each individual item in the list is an integer currently, and it lists the actual value of those things. And then if I look at my point variable, that contains the GUID value, which is a reference to the point that we created in the Rhino document.
How do you get that? Because it doesn't. Mine list is empty.
Sorry, say that again?
My list is empty. How do you get that?
Okay, so just click, see in this little periphery here, click wherever you want. Just type in, let me try something real quick. If you just set this thing equal, let's say, equals that. We'll just put in an arbitrary value because it's going to go up to whatever you put there. Let's just say, if I click here, see how the small red bubble comes up? And I run it. Now you've got all your things, and there's the point, the last thing I put in. Were you guys all able to sort of get the debugging thing to work?
But if it had a bug, how would it appear?
Well, first of all, if there was an error that occurred before that, the error would occur, and it would just, before it would even get to this, it would give you an error. But this is a way of tracking. Sort of, you go through, let's say, and you've got 25 different variables with lists and different types of information, and you want to actually just track what's in this particular variable at this particular time, right? I want to check halfway through my code that x actually equals, 5 or something.
So it's like a snapshot of that fact.
Yeah, and it will list up to the point where you click this little bubble. It will say what's in that variable at that point, if that variable has been declared before that. So let's say x equals 5, it will come up and you can check that. But if x equals some strange weird number, then you'll know, oh, okay, something weird's happening. And then you can kind of deduce, like go back and say, where is this happening? So it's useful for that, for kind of specifically seeing all the information that you have up to that point and making sure everything makes sense in terms of your order of operations. Okay, so this is sort of to your question earlier regarding the point coordinates, right? So there was a question earlier which was basically that, okay, we've created this point in the document, but now somewhere in my script I want to be able to extract, what those point coordinates were, but I don't want to use my original list. I want to use that object itself, let's say. So I ran here, rs.addPoint, it created a point in the document, it created a reference number to it, and it saved that reference number in this myPoint variable. And now later on in my script, I want to extract the coordinates of that point. One way to do so would be to then run this rs.pointCoordinates function. And the reason why we can use this particular function is that if we open it up, we see here that under parameters, what this particular function takes, what you give it, and what you pass to it in order to run it, is an object ID, which is a GUID, which is what we actually got as a return from our previous function and saved in our variable myPoint. So myPoint contains that reference number, which is this GUID number. And now I want to use that reference number to extract the actual point coordinates again. So I can run this function, and I know here, when I look at the documentation for point coordinates function, under parameters, it takes and is required to give it an object identifier. And then once you give it that object identifier, it does a bunch of its own things to then return to you the actual point coordinates, the numbers that represent this. What does it return? It returns a point 3D. So if we run that, point coordinates, myPoint, print point coordinate. So it returns 0, 10, and 20. And then if I debug this again, and I look at my point coordinate, this is actually a point 3D. So this is different than the actual point in the document. And this is going to be a bit confusing until you sort of get it. But you know, the actual point was created in the document, and a reference number was created to it. This particular value now contains the x, the y, and the z inside of it. And it's of type Rhino geometry point 3D. What's that?
Do you use the debugging?
I do, yeah. Yeah, very often. Yeah, I would definitely recommend constantly using the sort of print commands and also doing that as well in conjunction with it. I mean,
So now, to
sure,
get the x coordinate, you can, I think, say
dot x.
pt coordinate dot x, right?
Yep.
Because that was a...
Yep, absolutely. So, yeah, so if we were to run this debugging thing, and we look at the values that this returns, and we look at our pt core variable, which contains a rhino.point3d type of variable. It contains a value that's listed here. But then we can also expand this and look inside, and we see that there's an x, a y, and a z value inside of this. So that actually means that then if we were to we could actually do this, which is we could say x equals ptcore dot x, because x is contained inside of pt core. So if we do that and then we print x, it gives us the value for x.
And if you have 2 points within that list?
So the question was basically if you were to type 2 points and run this function in your list, so you have a list that contains 2 points, what's it going to do? So I'll show you. It's going to give us an error. So basically, let's say we define our first list of point values as, let's say, a list of lists. And each one of those lists that are inside of it are going to contain the x, y, and the z value that defines a point. So to do that, I'm going to say so now I've actually, by doing this, by doing the open brackets for a list and then putting inside of it an open brackets and closed brackets defining a list, comma, another list, I'm actually making a list of lists in this case. So this is going to define, let's say, 2 points, and I'm going to try and input this into this function and see what it does. So it gives me an error. I can then look in the errors that pop up at the bottom here. So it gives me these three errors. The last one where it says in module. So this last error where it says in module, it says line 5 in module, right? So that's locating where the error occurred in my script that I'm writing now. So line 5 is where it happened, and that's here. So I know that whatever my problem is that's happening right now is happening on this line. It gives me a message that says could not convert this thing to a point 3D. So it's confused as to how to take this particular information that I have in this variable that I'm then trying to input into this rhinoscript function. It's confused as to what that is, and it's trying to convert it, let's say in this case, to a point 3D, and it can't do that because it's actually 2 points. It's a list of lists. So before I go on and explain that, again, if you look at the bottom and it says traceback and it says the lines of code where the error occurred, it says in module, that's my script. That's explaining what's happening in this particular script. These other two are also locating where the problem might be somewhere else. So it's actually, when I look in the bottom here and I see line 59 in add point, this is actually, and then it has a sort of location, right, on the hard drive. And you can see this location actually coincides with the search path where it finds this particular function and tries to run it. So when you're debugging also, you can look at your code and say, okay, what's wrong with my code? Why does this, according to this error message, why does this not make sense? Why is it not working? And if you're still kind of like not sure what that problem is and you're kind of stumped over it, you can also go to the actual location of this function. It says line 59 in add point at this particular location, right? I just double clicked on that line and it automatically opens up that particular module. So I'll just so if this particular thing, if I double click on it, it opens up that particular module in space and it opens it up to the location where the error occurred. So it was both an error, it was an error that actually occurred in my script that I ran, but the problem that it had was when it looked to this other module, tried to run the rhinoscript function, got to a certain point in that rhinoscript function, and it didn't work, and it returned an error. So it's giving me sort of both things, so now I have actually two components of information to debug what my problem is. So here you can look, it says line 59 in add point. On line 59, there's a certain function that's run here, coerce 3D point. I'm not going to explain what this is, but basically, if you knew what this is trying to do here, it would also indicate to you what the problem is in your code, and you'd realize, oh, okay, it's trying to assign a variable called point here by taking an input, which we're inputting into it, and converting it into a single point, but it can't do that because I've given it a list of 2 points, so it's confused, basically. So anyway, that's a quick thing about debugging, is that it's going to give you information both inside of your own script and also inside of the location where there's a problem within the functions that you're trying to run in rhinoscript. So if I go back to my code and I say, okay, why is this giving me this error? I know that the error occurred on line 5 in my code, and I know that the description of this is that it could not convert it to a .3d. So then I go, okay, I've written this, I've made this variable, and I've run this function, and it doesn't know how to run the function with whatever I've given it. It's confused by what I gave it, and I gave it this value, my point location. So there's something wrong with that. I don't know what it is. So then what I could do as a starting point is to go, okay, rs.addPoint. Let me look at that function again. So I go to the documentation, and I look at addPoint. And I go through this, and I say, okay, parameters, what does it require? Like, what do I have to give it? It says a .3d or a list of 3 values. So because this particular function is called addPoint, it's not called addPoints, it actually wants one value, and in the form of a list. So stuff's like, it seems super dry, but at the same time, it's the way code is. It's like if it expects me to give it 3 values to define a point, and I give it 6 values defining 2 points inside of a bigger list, let's say, it's confused. It doesn't know what to do, so it gives me an error. So in this case, what I would actually do is sure.
It's not really different to Grasshopper again.
Mm-hmm.
Because remember in Grasshopper sometimes you had to, for instance, graft one battery. So because when we wanted to put it into, let's say, the other battery, it wasn't just recognizing the data. Or when you have to extract the list from an item, that's why you wanted to basically take something from the list. So if you look at it that way, it's really not something different to what you already know. It's just, it takes just a short while to get used to this, basically this setup. But it's really not something different.
Do you guys sort of understand what I was explaining in this last one? So why it is that it couldn't actually create the point from this set of information. Again, I'm giving it a list of lists, and it wants one list of 3 values. So it's confused and it won't work. So what I could do is actually run another function. So if I copy this, in this case, I can run addPoints. So I know if I go through here, there's actually a function called addPoints. In this case, it requires a list or a tuple, and it's a list of 3D points. So it's actually a list of lists, which is what I gave it. And it wouldn't work in the previous one, but it should work in this one. So if I run this again, my error is on line 10. Okay, let me just do this and I'll explain that. Okay. So I ran it. You can see that the 2 points are now on the screen. There were no errors. Printed these things. Let's just turn this off for a moment. Let me just do this. Okay, so now that works. So it's then returning a value with the addPoints and placing that in the variable myPoint still. And then I tried to use myPoint to run rs.pointCoordinates here. Which now doesn't work. And it worked before. Do you guys know why? Can somebody tell me why this doesn't work?
It's 2 points.
Right. And why is it that because it has 2 points that it won't work?
Show which one you want to play. 0, 1.
Right. So basically then it's giving me this error, and if I were to go back to point coordinates, it requires in the parameters that you give it an object ID, which we did before and it worked fine, but now it doesn't. So basically, now what we've done is this my point variable up here. We got the return from rs.addPoints function, and we tried to use that to run this other function, and it didn't work. So if we look back at the addPoints function again, which is, let's get rid of some of this stuff. It returns a list of GUIDs. So it no longer returns a singular GUID element. That's actually returning to us a list. And now, this function that we were trying to run, we've given it a list, but it actually wants just a GUID value, so it's confused, and that's why it won't work. So if I wanted to list the point coordinates, let's say, of my first point that was created in the document, I could take this variable and do that. So basically now, it's a list. My point is a list. Let's call it points so we're not confused. So my points returned, rs.addPoints returned a list. It placed it into this variable. I then tried to use that variable, and I'm actually listing the first item in that list, which is a GUID, which is what this wants. You have to give it that in order for it to run properly. So if I run that, it works fine. And it returns, it prints the coordinates of the first point that was created.
There's no command that would bring back coordinates of a list of points?
Sorry?
There's no command that would bring back the coordinates of the multiple points?
Well, if you think about it, we already have that, right? We have that here.
Yeah.
So why would, we would keep that in parallel and we would just use that variable, right? Because it's still, you still have a list of point coordinates that are in sync with a list now of GUID values that have been returned.
Mm-hmm.
So this my points variable now contains a list, let's say, with 2 things in it that are the references to the 2 actual points that we created. And you have a secondary list that's just the actual coordinates, but we know that those match up, right? So if we want to run a function, in other words, that needs an ID value, we have that in a list, and we also have a list that contains the coordinates, so we can extract it.
Like make the points in a less direct way by doing an operation like an intersection or so, and you want to get all the coordinates out of it again without actually giving in the coordinates first. There's no.
Another thing could
In
be
that case, it would
the
probably
common to
return
that
that.
is like a for loop where you work one by one through the items in a list. But we'll get to that.
But also,
in the next sessions.
for example, if you look at, let's look at that as an example, right? So your intersection, let's say an intersection of curves. So curve to curve intersection, right? So in this particular case, you would give it 1 or 2 curves, right? So it says, basically it's saying the parameters to run this function are curve A, which it says is required, so you have to give it at least 1 curve, or curve B could also be, so you could be trying to intersect 2 things together, or you could just be looking for a self-intersection, whatever. And and then you can give it an optional tolerance. So some of these things are optional, some of them are required. And then it tells you what it returns. So this is all the information that it's actually returning with this. It's returning a list, which is a two-dimensional list, basically, which will give you both an indication, which is a number, of which type of intersection it is first. So whether it's a point or an overlap. So if it's two lines that are coincident and they're in the same place in space, it's going to tell you it's going to put a 2 in that place in the list, and it's going to tell you that they're overlapping. But if they're crossing, then it's going to put a 1 there, and it's saying that they intersect at a point. So this gives, like, this will return basically a bunch of different information. That's one thing. So the second thing it gives you is a point 3D. So a point 3D is actually different than adding a point to the document. It is actually going to give you the coordinates back, right? Because, for example, if you look down on this rs.point coordinates returned a point 3D, which actually just gave me point coordinates, right? So when I ran that, it listed them here. So if I run this intersection event, curve intersection, it's going to return the point 3Ds of the intersections, and if there can be an infinite number of intersections. That's why this is a two-dimensional list of information that it's giving you back for each intersection event. So it's actually giving you the point coordinates back, but it also returns a number indicating the parameter along that curve where you can extract information from it to get that particular intersection. Do you know what I mean? So it depends. I mean, all of the different functions return different information. So, I mean, like in this case, it will actually give you a list, you know, that contains these intersections as coordinates. So, I mean, basically what to get from this is that it's really important to know what you have to give the function and what you get back from it. And that's why, for example, running the function type, you can look at a variable and print what type of variable it is, so you know, oh, okay, I tried to run this function and it gave me an error, and then I realized, well, this variable is not actually you know, a serial number to this object in the document, it's a list of them. And I'm trying to give something a list that wants an individual thing. So it's kind of important in terms of debugging, because you're going to start doing this and you're going to get super frustrated immediately because it's going to give you a bunch of errors. But actually, if you're really systematic about it, you can start to break down, well, what's the error? Which line is it on? Okay, I ran a RhinoScript function. It's saying it's on that line. Let me look back at that function at what I need to give the function to run it properly. And what did I actually give it? So I'm going to then look at the variable I tried to give it and match it up. Is it the same thing? No. That's why it's giving me an error. Does that sort of make sense as a starting point? Okay, so then let's just real quick, let's take this and let's make a line from it. So we have these 2 points and we're going to make a line. So I'm going to go up and define rs.addLine. Actually, I'm going to make it 3 points. Sorry, I'm going to make a curve. I'm going to do curve instead. My curve. So if I look down below, it's telling me help function for add curve. It's telling me it needs points, and the degree 3. It's telling me one of those things is required and one of them is optional. So I'm going to tell it my list of points. And I'm going to then tell it what degree of curve I want it to be. So let's say I want it to be like a degree 3 curve. If I run that, it's giving me my curve using those 3 points, but as a degree 3 curve. So if I look at the control points of that curve in Rhino, you can see it's these 3 points.
Can you change them in Rhino?
Yep.
And then it will change your speed back in...
Nope.
No.
Not like Grasshopper in that way. What's that?
It keeps the same reference, right? It keeps the same GUID. Or
Well, the GUID is going to be lost as a variable when you run the code once.
Right.
It's not going to. You'd have to save it, right? But yeah. Sorry, say that again.
So back to the code, so you put in the list XYZ values instead of constant size. But you could have put my function.
Let's try that. So that also worked. And that's the thing, there's some of these functions are resilient enough to understand a list of points. That's what I brought up before. It was like that coerce curve function, coerce points. It attempts to understand what you mean, but if it can't figure it out, obviously it's going to be screwed up. But certain functions, for example here, I was able to either give it the reference to the points, or I was able to give it the actual point coordinates. Both of them were successful in creating a curve. I can't remember actually if that works in, it works in Maya, but I don't know if it works here. Let me try that real quick. I think you're right, actually. Yeah. Let's say if I put a 1 in here, created the same curve, only it made it a degree 1 curve. Sorry, say it again.
You can connect the Grasshopper to Rhino data. But here you have to create all the data.
You create all the data here. I mean, in general, that's what you're going to do, yeah. So when you run this, it's going to create data and store it in variables, and when it completes, it's not going to stay in those variables. Sorry. Yep. Sure. So I'll do that real quick. So basically, let's then create get points. So let's say I've got a bunch of data that I've already drawn. I've got like these 3 points or whatever, and I want to create a curve. So I'll do this. I'll just create a bunch of points. And I want to use these curves to then draw, let's say I want to draw a curve through these points in my code. So I'm going to comment this out real quick. Get points. So there's a function for getting, you can get things from the document, and let's open that up real quick. Okay, so I just added, rather than having a sort of manual input of a list of numbers for my points that I'm drawing my curve through, I ran another RhinoScript function that's called getPoints. So if we open that up and look at it, getPoints returns a list of 3D points if successful, and it basically asks you to pauses for user input of one or more points. So you run the function, it says pick point, and I picked, let's say I pick a different set of them. So it then used those points, it returned a list of them, that then put in that list of information into my point locations variable, and then ran the script exactly the way it was already set up.
It's a whole new world opening up.
In general, is it
Sure.
possible to steal the data structures from Grasshopper, like how they read the word, like it sort of varies already, and use that, or would you have to recreate those?
You mean in terms of, for example, there's like the data tree elements, right?
Yeah,
So
yeah.
that's what you mean by that, the fact that it has sort of a hierarchy of information?
Mm-hmm.
You can write, let's say we were to write this exactly how it was written here. You could take this and put it into a Grasshopper component, and there's sort of the the inputs and the outputs of Grasshopper components, right? In the inputs, you can sort of tell it which type of information is coming in. So you can get access to it as a list. So it would be, let's say, like a flat list of, just as we have here, of values. But you can also input it as a data tree. So you could actually access the information on the layers as it's already organized up to that point. It's just a different type of variable. So then you have to use, if you're using that, then you would have to use the data tree functions, not list functions, let's say. So list, let's say you do append and extend and those things that we were showing earlier. With data tree, you'd have to use like add branch and some other functionality that's built into that type of data.
Do you have like any image processing websites with your project which have been done?
Sure.
Well, what's the difference to scripting tools?
Nothing. I mean, script, writing code is, no matter what language you write it in, is going to have, let's say, you could write what we just wrote, 10 different ways in Python or in a different coding environment, right? I think personally, though, the primary thing that makes Python really powerful is one, its flexibility. It's really fast to write. Like you can tell that things are very simple. You don't have to define every variable, write a lot of extra code in order to do a very simple thing. And also the fact that it's object-oriented means that you can create your own classes of objects, which I'll talk about a little bit down the road, but that's super powerful. You can create like my superpoint class, right? And then maybe that class now contains a point, but also other information at that particular point. So, for example, RhinoScript was written in VB.NET, and it didn't have dot capability. So there are some elements that make it really powerful. But it's more in terms of the flexibility and the ease of use and things like that. But also, you can use it with Maya, you can use it with whatever, and it's a lot more flexible.
When you're using it with Maya, a lot is the same, so?
A lot is the same and a lot is different.
You use different names probably.
Yeah, for example, like the whole thing that we went through in terms of the references to an object in this document has to do with how Rhino runs. When you run Maya, for example, if you create a variable and you assign something to that variable and you run the script, that variable stays there actually. It doesn't go away. So it always exists. The data stays in the sort of document. So there's some differences, and also just the way that you reference things is different. But the syntax is the same. It's still lists and floats and strings and whatever.
But instead of points, you would use vertices.
Yeah, but it would basically be the same as a point, right? You create like point locators, let's say they're called, but it's the same as creating a point in Rhino, basically. Does this sort of make sense, or is it just like overwhelming, or is it super boring, or is it like...
Oh, great.
Does it make sense so far, or do you guys have any... Just, shout out any questions that you have.
I think as an introduction, it's at a really good pace. It's good.
All right.